Waze is a multi-model video generation model that unifies all aspects of masking, editing, image-to-video, and text-to-video combined. Released by the researchers in the Alibaba group, it is meant to address the unification of the already existing techniques like pose transfer, subject recreation, canvas outpainting, subject inpainting, and many more tasks that can be achieved with individual models, but it is the first model in its class to combine all of these. They classify the intended goals of the inputs in 4 categories: text-to-video, image-to-video, video-to-video, and masked video-to-video, and any composite of these 4 goals. Now we're going to start with the architecture. Showing the VCU part, the model takes input in the form text plus image plus video, which is repackaged in a singular input array called video condition unit. It is formed of a string text prompt, video frames F, which are normalized RGB values for each pixel on the screen, and masking frames M, which are Boolean markers showing which part of the input video or image will be edited. The format of the Boolean masks and the frames change based on task. In case of text-to-video, all frames are marked as white, and the Boolean mask is marked for all the frames, signifying that every single frame must be reconstructed from scratch according to the text prompt. For image-to-video, additional reference frames RI are inserted on top of empty frames. The Boolean mask keeps the reference frames unchanged, but marks everywhere else to change to create a video with the style and identity information from the reference image. For video-to-video, the frames depend on the input video, and an entire new video is generated where each frame is subject to changes by the mask. In mask to video, the changes are only applied to the inputted masked frames mi equals 1. The diffusion transformer, the original text-to-image model architecture, is reorganized to be fine-tuned on the VCU input. Waze adds additional tokenizers for the frame and mask values, which work in 3 steps. First, depth and pose are encoded into the frame values, and then the frame values by the masks are split into reactive and inactive frames. Reactive frames are the frames that are marked for change, and inactive frames are the frames that are to be kept. This is called concept decoupling. The next step encodes the reactive frames, inactive frames, and the masks into the same latent space of X, turning them into the shape of N cross product H cross product W, where N are number of frames, H is the height of each frame, and W is the width of each frame. The last step embeds FC, the reactive frames, and FK, the inactive frames, and the masks M by their channel dimension, which is the variable D that holds the information from each of the matrices, so number of parts to change from DC, parts to change from DK, and the Boolean values of the mask from DM, which are then stacked on top of each other. Then they tokenize FC, FK, and M. The next larger step is fine-tuning. With the tokenized information, one can either A, fully fine-tune the classical diffusion transformer directly based on this new input form and stack the N frames to create a video, or B, selecting and copying some transformer blocks from the original diffusion transformer to create context blocks which share the text with the DIT block and process the context frames themselves. They reinsert the output of the context block to the DIT blocks. With this, they only train the context embedder and the context blocks themselves. The resulting architecture is able to generate pure AI videos and also edit existing real or AI videos, which wasn't previously possible with a singular model. If you watched until now, would you like to lose out on content like this? Then please don't subscribe and don't hit the like button. Cheers!